Brilliant. So yeah, thank you, Owen. I'm Brett from Menlo Security. This isn't a sales pitch, so I just wanted to give you a little bit of context in case you haven't come across us before. We're a pioneer in browser security. We've been operating since 2013, so a little over 12 years. We have around 1,000 customers globally, around 10 million users on our cloud. You can also run us on-premise. There's a few different architectures. Excuse me, a bit of cold. Work with all different sectors. We've got customers in all shapes and sizes. Biggest in the UK is HSBC. Biggest globally is US Department of Defense with a little over 3 million users on our platform daily. We serve a multitude of use cases, but today, as Owen said, we're going to focus in on the modern workspace. Got this one from a Cisco presentation. I thought it was quite apt. It really just tries to show what a hugely complex, hugely costly labyrinth the security industry is these days. You guys have obviously got the hardest task of identifying risk and identifying the best controls to mitigate those risks. I think one thing which is kind of commonly accepted and clear is web and email are still the two big inbound attack vectors by far. It's a decades-old problem. Vendors like ourselves keep creating new instances and controls and features and tools, but it's not gone away, and that's despite all the continued investment from companies like yourselves. It's just kind of crazy, The more you're spending on a yearly basis, and the problem isn't going away. One of the things which is kind of important in that context is most of the tools that we've been using to date, they're all simplistically detection-based. So they're trying to figure out, is something good, is something malicious? Obviously keep the malicious stuff out and allow you to get to the good places, sort of thing. The fundamental of having to make that decision means that they're not going to be accurate 100% of the time. So they're prone to false positives, false negatives, things like that. Wrap that around with all of the training and all of the security awareness programs that we run, you guys run, I'm sure, we're still getting users clicking on links. We're still getting users hitting sites which are getting some sort of malicious code or content reaching their machine. Some of these are from us on the periphery, just what we see in our cloud. Some of the text is small, I apologize for people at the back, I'll try and make it clear, but one of the huge kind of shifts in focus is how users, maybe since COVID and since digital transformation has started moving the services and systems that used to be on your networks into the cloud, users are also working remotely a lot of the time. They're working from all different locations. They're not simply in the corporate network these days. What we're seeing, Google actually brought this stat down at the bottom. They ran a survey and they said, users are roughly spending about 75% of their day in a web browser, or we're sitting on Teams, on Zoom, WebEx, all of those sort of collaboration tools. Attackers are well aware of this trend because we're seeing that they're hugely targeting the web browser as the low-hanging fruit, the entry point to an organization. Chrome, I think, came out with, it was at least 1 0 day every month last year, but attackers are just continuously targeting the browser, exploiting vulnerabilities in it or in vulnerabilities of all the tools and applications that browsers use to render various types of content these days. So PDFs, Office files, all that sort of stuff. The other points are kind of tying in with what we're seeing. So up in the top left, so we're seeing around 75% of phishing links that are on our platform being originated from benignly categorized websites. So an easy way for an attacker to get someone to click their link and to bypass your controls is to send it from LinkedIn, to send it from your mobile phone, to send it from a site which they've gotten classified as business and economy, and you're not blocking this URL category in your proxy. Most of the controls at that point become kind of irrelevant, sort of thing. Far right, we're seeing a similar trend with malicious code and content. Around 70% of the attack attempts on our platform we're seeing coming from good locations, which if you're just relying on URL filtering, AV, sandbox stuff, which is making that decision, it becomes really, really challenging. Password protected files down at the bottom, we see around 2 million of these on our platform through our customers' data every month. If you can't open those files and scan what's in them, it's very hard to determine whether there's good content or bad content. And there's always a lag. So we're seeing at least a lag of 6 days between when our product essentially isolates something, users protect it, but then we see the database changing, 6 days later to catch up and say, hey, this looks like phishing or something like that. To try and add a bit of context to what I'm saying, tons of other companies, security companies, are reporting the same sort of behavior, much bigger and well-established ones than Menlo Security. The use of evasive tactics, it's very prevalent out there. It's just a hugely popular way for attackers to try and bypass the existing controls, which have been around for decades, and they know their vulnerabilities, just like we generally do as well. To try and highlight a few of the techniques being used, these are some of the ones which we're commonly seeing. So starting from the left-hand side, so using dynamic file downloads. Something which has become, oh, my bad. I think there's actually a timer on this slide by mistake. I'll try and talk quickly. But HTML smuggling is whereby an attacker breaks up their file into binary chunks and inserts it into the HTML. That gets reinserted and reinstated using JavaScript on the client browser once it's downloaded. Super simple way. If you're looking for a file on the wire, this doesn't appear as a file, so you can't scan it by AV or Sandbox, anything like that. The next one, using other paths other than email. So sending you links from WhatsApp, sending you links from LinkedIn, sending you links from Facebook, whatever marketing system you might be using. Evading categorization, that's the one that we talked about, where things are being served from these good locations. And the last one is using phishing kits, which actually leads on quite well to this one. Palo Alto recently stated that 90% of the phishing attacks are using these phishing kits. They're publicly available, you can buy them, sets you up, makes the kind of the entry level to phishing, much lower. It's easy to do that sort of thing. You couple that with generative AI, these guys are now, creating emails in all different languages, well-crafted emails, and then using readily available kits. In terms of what we're seeing, excuse me, as the evolution, it's kind of moved on. It was primarily a misspelled Microsoft login domain or something like that, Whereas now, if we're seeing it over time, we're seeing other channels being used, like social networking or WhatsApp or these other channels. I think Windows 11 is about to support iMessage, the iOS messaging application. I should have checked these timers. But you can now be installing your iMessage application on your Windows machine. That means users can be clicking their links within dodgy text messages on their environment that's trying to attack. And likewise, we're seeing more of the attack in the middle, trying to steal your MFA credentials. We're seeing it with Okta, with a number of different MFA providers where that's come through as an attack. Something which is kind of coupled into all of that is what we see as the evolution of the browser. Whereas we used to have all of our applications on the machine, most of those are now moved into the browser. The browser is this hugely complex, almost operating system sort of thing. Whereas, you used to have your music, your documents, your videos, all that sort of stuff separately, and your security controls were targeted at, securing that endpoint itself or the operating system on the endpoint. It's now become a case of the browser is pretty much your endpoint, which needs the security controls around it. So one of the things which we try and push or recommend, when I get a new laptop, I get antivirus on it. I've got backup, I've got all sorts of security controls. I get a profile pushed down from corporate that dictates, whether I can use removable media, all that sort of stuff. We don't typically get the same thing for browsers. You got your Chrome, your Edge, maybe you use some other browsers, Firefox, etc. But these browsers, Chrome, which is used by Edge and by Chrome, it's got over 1,000 settings in the backend that you can enable or disable. A lot of the customers that we work with, they're trying to manage these settings, often manually by using like group policy or something like that. But what we kind of need to do is to have frameworks like the CIS framework or CIS level 2 to enable or disable all of these features. So that's what we try and enable, to essentially posture assess and harden your local architecture, but use a browser away from that to do the actual heavy lifting or browsing, essentially. So ours is really centered around really kind of 3 pillars. So firstly, that capability to manage or posture assess your local browsers. You pull your configuration in. You can harden it against general standards like the Center for Internet Security, which is CIS, and then you can push that down. We do also have other forensic features whereby we can store information and replay sessions and all sorts of cool and funky things. If anyone's interested, we can give you a demo later. And then the 2 other aspects, one is protecting your users. So that's protecting your users whilst they're connecting to the internet, whether that's clicking a link in an email or browsing or anything like that. And the second one would be protecting those applications. So that would be our secure module. And that's where we can essentially flip this around to provide access. So I guess probably a lot of you have got contractors or users working with BYOD devices or users working from locations that they might need to have VPN enabled to get to certain applications and things like that. So using this, we can essentially provide that access without requiring VPN or VDI usage or anything like that. So just to kind of give you a rough how it works, we're essentially using this, what we call secure cloud browser. So in a remote container, either in our cloud or on premise, user connects to us, where they would usually connect to the web page, say CNN. They would connect to all of the third-party services, content distribution networks, advertising networks, everything that's needed to essentially make that page. So they would then pull that down to their machine, execute it in the browser, and then the browser essentially displays or renders that page, right? But it's during that fetching of all the content that you could be inadvertently exposed to malicious code or content or phishing sites, things like that. So what we do is we move that execution and the fetching away from the endpoint. So instead of the user connecting to CNN, that's what we would do. So we get a secure connection between us and the user, and then we do the browsing on their behalf. Whole point there is we create this kind of logical air gap between the user and the internet. Kind of bulletproof glass, no active content reaches them, which means that no vulnerabilities can be installed or attacked locally on the endpoint itself. We do the same thing in front of applications, whereby your contractor is air-gapped from your secure application, So a couple of the security benefits. So as I say, the isolation will stop any active code or content. We're not trying to figure out whether it's good or bad. We simply provide this kind of one-way view of the traffic. We extend that to documents. So we turn documents into HTML5 objects. If there's some sort of weaponized document, that never makes it through to the user. They get a copy of the document, sort of thing. And one thing which we've built on top of this is something which we call heat shield. So we do this time of click analysis. We're looking at risk scores. We're looking for commonly impersonated brands, so logos. We're looking at the page composition. So, is there a login form? Is there a password field? All of these sort of telltale indicators, which we use all combined together to say, hey, this looks like it's phishing, rather than something coming from business and economy or something like that. We have also wrapped around the common services that you would expect, DLP, watermarking, all that sort of thing, CASB, those other services as well. But these are kind of the main sort of security features within that, which could help with securing that modern enterprise or modern workspace. I'll just build this up and I'll leave you with this. But just some key takeaways. We're seeing evasive tactics and techniques being used all the time. So having something like this, really safeguards and mitigates the risk of that. Most of the tools that are existing and out there, they're all based on that detection, that decision-making process. So this is a kind of a proactive or a prevention versus detection type scenario. The other one is using that AI or machine learning that we have enabled to try and identify phishing in real time. And the last one is really that us having that context of being the actual browser gives us this unparalleled view of what's actually going on, during that session, during everything that's playing out in there. I think that's about it that I had for you guys today. So thank you guys very much. Really appreciate your time. If there's any questions, I'll be happy to answer them as well. Really, thank you.